Hello guys, welcome back to our tutorials in which we're learning AI agents. In this video, we're gonna start learning about how you can uh, differentiate different type of agents between different types of architectures. So, in this video, let's learn about prompt chaining. This is one of the orchestral architecture systems in which you have three agents all lined up in one sequence. So, as the name suggests, prompt chaining is that you just chain up all the agents together and they would make a workflow. Now, they have some pros, of course. The, the best advantage of this type of AI sequencing is that it improves accuracy and quality. Because if you see, each AI agent is dedicated for a certain task. Like this one is for outline writer. It behaves as an outline writer. The next one is the evaluator, which just evaluates what the previous agent has written. And the next one is the block writer. So each step focuses on a specific task, reducing errors and hallucinations. So instead of just having one agent do all the tasks, you have three agents over here which are dedicated to doing different tasks. The second best advantage of prompt chaining is that since you have just one action going on at one step, you can refine or tweak individual steps without affecting the entire process. So suppose I want to change this model to something else. I'll just deal with this step. It's not like I'm changing for the rest of the workflow. So, and even if I wanna change the way this router works, I can just go into the settings, go into the configuration, and write a system message accordingly. So it's really simple to refine the task and edit them. The third best advantage of this type of orchestral architecture is that specialization leads to more effective AI agents. So, although if you are requiring more agents, you are consuming more credits from the multiple AI LLM models that you're using, you are improving the performance as well. You see, the effectiveness of the AI agents increase if they are just focused on doing one task. That's why the agents become a specialist rather than a generalist, improving reliability. The fourth one is easier debugging and optimization. So, suppose there's a problem while executing this workflow, and in a normal AI agent architecture, you would just be confused where exactly the problem has occurred because a single action, I mean, all of the actions have been taken by that particular AI agent, and it's difficult to figure out where exactly the error has occurred. But in this kind of prompt chaining architecture, you can just open the AI agent, see if there's an error that has occurred. If not, just close it and go on to inspect the other ones. It's as simple as that. So debugging and optimization has become more easier. If an output is not ideal, you only need to fix the weak link rather than redoing everything, of course. And the fifth and the last best advantage of why you should be using AI agent in this prompt chaining manner is that it's more scalable and reusable workflow. So a structured step-by-step workflow can be repurposed for different use cases. So for example, I don't want to write a blog. I want to make some Insta post, captions for Insta post. So instead of making another workflow from scratch, I will just go here and edit the following requirements accordingly as per what the Insta captions demand. And I would not need to change the whole thing. And instead of post to docs, I will just make it go somewhere else. So, and one more important thing is that we can use the LLM models according to our needs. For example, for outline and writing, we are using 2.0 Flash. For the next evaluation, we are using 4.0 Mini. Although it's a little bit more expensive, but it's still more effective for performing this task. So we can use dedicated LLM models for executing a certain task, which is another advantage of prompt chaining. So in this video, we learned about one of the four architectures of AI agents. And this one was prompt chaining. In the next one, we will see how the routing architecture works. Till then, stay tuned. Thank you.